Good morning, good afternoon, or good evening, and welcome back to another DevOps.com program brought to you by Techstrong, Google, and MongoDB. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, there are just a couple of housekeeping notes I need to cover. Today's session is being recorded, so if you miss any of our session, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. On that right side of the screen, you'll also find a chat tab. And I'd like you to start warming that up for me now. Let us know from where you are joining or maybe what role you play in your organization. If you click the Handouts tab, you'll see there are a few resources that we've just added for you. So feel free to click on those and grab those links. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our conversation today is Ask the Experts, Simplified Data Services Orchestrations in Your App. I'm joined by Mofizur Rahman, Developer Advocate at Google, and Joel Lord, Developer Advocate at MongoDB. So Mofi and Joel, thank you both for joining me today. Mofi, you want to go ahead and get that screen share pulled up and get us kicked off?
Yep, coming right up. All right, just give me a thumbs up when you see it. I am seeing, okay, fantastic. Hello, everyone. My name is Mofi. I have old and good friend Joel with me here today. Joel and I met first time at a conference of all places, and we shared socks. So that's how Joel and I know each other. I gave him new socks, not shared socks off my used ones. So
yeah, that sounded a little weird there.
Yeah, it did. The moment I said it, I was like, okay, how did we share socks? No, I had pairs of socks that Joel did covet. So I shared new extra socks with Joel. So we're going to talk about today. Again, my name is Mofi. I work at Google. I work in the Kubernetes team. I'm a developer advocate there. And Joel, want to introduce yourself?
Yeah, sure. My name is Joel. I'm joining from Canada today. I see that there's participants from up here as well. And I'm a developer for MongoDB. So I've been there for about 18 months. And yeah.
All right. So again, we're going to talk about MongoDB. We're going to talk about Google Cloud. But the main thing we're going to talk about is simplifying data service orchestration in your apps. And ideally, those apps are running somewhere in the Kubernetes-like environment. So the first thing, like many things, we're going to talk about Kubernetes. Kubernetes turns 10 this year. So I don't think we have to introduce to that depth. But a little bit of a word origin of Kubernetes. It comes from the Greek word helmsman, which is also the root of the word governor, which I didn't know. I learned while doing research for this, which is a lot of fun. As I said, Kubernetes turns 10 this year, originally as a open source version of Google's internal tool Borg. Kubernetes was created in Google, then donated to open source. Now it is one of the, if not the biggest open source project in the world. It's written 100%, it's open source 100%, and it's written in Go. So again, if you are not familiar with Kubernetes, which is probably unlikely, but if you're still not, what is Kubernetes and why do you care about it? For the longest time, when you're deploying a building application, you have the challenge of, okay, it works on my machine. I have to hand build this machine setup, and if something changes, it's like a week-long process to rebuild that thing again. With Kubernetes and containers, you now have a way to define your application. And now once you have done that, any place that can run those containers, now you can just run the application without having to redo the work over and over again. So you also have a lot of built-in practices that comes with Kubernetes, like release automation, a lot of the CI/CD practices that were available before, but with Kubernetes now they have gotten second life, and now they are common industry standard across all company sizes. Now people can take these best practices that was only available in big companies. Now they can replicate those same behaviors in their small to mid-sized companies, which can speed up deployment times and remove failure from the pipeline as much as possible. So quickly, overview of Kubernetes architecture. Again, we talked about this open source container management is automation. You have imperative design. And the features you get out of this is it supports both stateful and stateless. It has autoscaling built in. It has resource limits and quotas you can set up. You can extend Kubernetes in numerous different ways, from open source standards, as well as a bunch of CNCF projects, as well as third-party paid software, and portable, right? Like if you're using Google Cloud today, which we expect you are, but if you're not, if you're using some other cloud provider and Kubernetes there, and tomorrow you decide, you know what, things Mofi is telling me about GKE sounds really exciting, I want to try it out, you could do it without having to rewrite your entire application stack, which is really exciting for folks. So if you're talking about Kubernetes, you are probably talking to Kubernetes using the kubectl CLI, and you're talking to the kube API server. Kubernetes has like a giant control plane that controls every aspect of that cluster, what's going on. On top of that, you have etcd that keeps state, and you have kube scheduler that makes sure that whatever resource you have in your cluster can be accessed by the kube API server. And then you also have the cloud manager. This is where different cloud provider magic comes in. When you are using something like GKE, which is Google's Kubernetes Engine, you are talking with using the Kube Cloud Manager that knows how to talk to Google Cloud, that can give you different resources, give different load balancers, volume provisioning. All that stuff is happening underneath at Google Cloud level, and Kubernetes have this adapter to do that for you. Finally, you have the Kube Controller Manager that controls access and controls what is happening in your cluster level. And where your application goes is the Kubernetes nodes. You have the kubelet that keeps communications with the control plane, and kubeproxy that handles networking. So when you have a request coming in for one of your load balancer, kubeproxy is the way it will figure out which pod to direct the traffic to. And now let's quickly talk about Google Kubernetes Engine. What is it and why do we care? So Kubernetes is powerful, maybe too powerful at times. Maybe it gives you too many options to kind of tinker around. So people were asking for opinionated solutions that you can just deploy. You can just deploy and get the best learning that we have done as Google, building Kubernetes from ground up. And how can we help operationalize that workload for your use cases? That's what Google Kubernetes Engine is. So what we have learned how to maintain Kubernetes clusters internally for our use cases, as well as we can give that same knowledge out to the world so that you can use it too. So GKE has many features. A lot of that are available in open source Kubernetes, but we have added our knowledge of running SRE practices inside Google to fine-tune that to the best of our abilities. So auto repair is fully managed. We have auto upgrade built in to GKE, seamless integration to other Google services. If you're doing AI things in Google or other Google Cloud services, you have seamless integration between those things, as well as networking, like Google's global network system is available through GKE as well. So you can get the best of Google's network in your Kubernetes environments. So for a user, Google will actually maintain all the control plane stuff. So you don't have to worry about, okay, how do I upgrade? How do I deploy Kubernetes? All of that is done. You click a button or send a command through your gcloud command, and the cluster is ready for you. You as a user are only responsible for the node stuff and your application. Well, that is not 100% true anymore, because we also have GKE Autopilot, where we actually take care of the node stuff as well. And you as a user become only responsible for the application you write. So if you were to look at a chart of all the things you need to do in an infrastructure management system, you are taking care of control plane, worker node, security, patching, reliability, scaling up and down, monitoring, and all of that. All the great things that you have to do just to get the benefit of the green part in this circle here, right? You only honestly care about the application that you're building, but to the service of that application, you end up having to do all these other 7 things. And that is true for Google Kubernetes Engine, like GKE standard that we have. But with Autopilot, we can actually go a couple of steps further. We can say, you know what? You also don't have to worry about your nodes. You also don't have to worry about security provisioning, because all of that will be taken care of. You only pay for the pods you run. So you only write application. And this takes Kubernetes to a more serverless-ish design, but also at the same time, giving you full APIs of Kubernetes. So it's kind of the best of both worlds, where you have the full control over your infrastructure, but without having to worry about infrastructure. That's what the promise of serverless was in the first place. And I think with GKE Autopilot, we can get even closer to that dream. All right. So couple of the next things I'm going to talk about, we're talking about them because we're talking about data, and for dealing with data, we need to know these things. So in Kubernetes, the way you get like storage is by volumes. And the volume we need, because we're trying to run with state, we're talking about running databases. MongoDB is a database. And to run with, to store those data, to store those state, we need some sort of way to get those volume provisioning. So Kubernetes have ideas of persistent volume. And in GKE, you have access to those volumes as well. You could actually attach NFS if you need to, but by default, GKE has a bunch of the storage classes that you can access. Yeah, so again, if you're trying to run things like MySQL, Redis, Zookeeper, obviously Mongo, you could do that yourself. Now, one of the things I see questions a lot about is that, oh, can I now run stateful workload in Kubernetes? The answer for the last few years have been yes, but. And the but part is, did you run stateful workload before on your own, right? Was that a skill set that your teams had? And if that is not the case, just because Kubernetes supports stateful set, that doesn't automatically make your teams experts in being able to manage databases, scale them up, shard them properly, make sure that data is replicated, migrated, and failover protected. All of those things are skills your teams already need to have. And if that is not the case, oftentimes for most teams, the right answer is look for a managed solution that gets you almost 90 to 95% of the way there and start working from there. There are definitely use cases where like running your own like database is the right answer. But in my experience, about for 90, 95% of the use case, that is not the case. Okay, next. All right, and finally, we're going to talk a little bit about operators. And we want this session to be more demo heavy, not like talk heavy. So operators, and I'm talking about operators now because we're going to touch upon a little bit about Atlas Operator towards the end. So it makes sense for you to have some understanding of operators, what they are. So first of all, the question of operators, it came from what if we had like SRE folks for our application just sitting within the cluster, right? Imagine back in the days where you have these system admins sitting in these data centers, and when something went wrong, they ran quickly to the hardware rack and fixed it live as problems occurred, right? That is something we're trying to replicate using operators in the Kubernetes world. So in Kubernetes, everything you can think of as a reconciliation loop, like your deployment, your jobs, everything that is running, it has a loop that is constantly listening for the state of it, right? If something goes wrong, you can go and fix it. With operators, you can extend that behavior to any and all application that you yourself write, right? In the example we're going to see later, we're going to see how you can use an operator to let Kubernetes create a MongoDB database using Atlas, as well as set up users, all these things without having to go to like a UI console and click some button or use some third-party tool. You can do all of that using a declarative model of Kubernetes where you can define everything via YAML. You can deploy all of that using a single CI/CD pipeline. That is going to be the benefit of it. So this is going to be my part of the presentation. I'm going to pass it off to Joel, who's going to talk a little bit more about MongoDB as well as MongoDB Atlas Operator.
Thank you, Mofi, for the intro to Kubernetes. That's great. So yes, well, you've already heard about what is Kubernetes and how it can help you. But when it gets to configure, as Mofi suggests, when it comes to configuring your databases on Kubernetes, it can get really, really tricky. Now, there are different ways to deploy MongoDB into a Kubernetes cluster. And you could use your Docker images directly. So MongoDB just released last week, actually, their official images. They used to be maintained by Docker, but now they have their own maintained images, so you can get the most recent version at any given time. But if you simply deploy MongoDB as a container, that can be a little bit tricky. You have to take care of all that stateful, managing all of that state, making sure that you've got all the volumes in place and all of that stuff that goes around it. If you want to use it for development purposes, the MongoDB community server Docker image is great. It will work wonders. It'll work on your machine. But when it gets to deployment, that's when it gets tricky. Now, you can use there's 3 variants of MongoDB that you can use. As a matter of fact, there's community version, which is free for use. There's the enterprise advanced version, which is a version that you can use and install on your own machines. Or there's the MongoDB Atlas, which is I don't know. I don't think everybody knows about it, but it's a great way to get started with MongoDB. And there's a link in the handout section of the chat where you'll find a link to get started. But basically, it'll give you a fully managed or access to a fully managed MongoDB cluster. There's a free tier that you can use, and it's free forever, and you get like 500 megabytes, which is more than enough to get started and start exploring. Once you get started, you have something that looks a little bit like this, and then you can decide where you want to store your data or what type of server that you want to use. So you can use that free tier as I've mentioned. And then you specify that you want everything on Google Cloud because you're already using the Google Kubernetes engine. And then you just pick the region that you want to use. You'll be able to deploy your free tier right there. Once that server is started, it takes a few minutes to get deployed, and then you'll have access to a free cluster that you can use, as I said, or you can even have a production server as well if need, or you can upgrade to it if needed. Once you have this, you can load some data, some sample data. And if you're not familiar with MongoDB, that's a great way to get started. Using that sample data set will provide you with a bunch of different collections and different things that you can explore. And it'll give you ideas on how to use MongoDB from a developer perspective. I have this, I'm doing the bake show trick here. So I have a cluster which is ready, already has all of those data sets. But you can see here that I've got just a bunch of different records or documents. And you can start exploring those and see how people are using MongoDB, again, from a development perspective. If you're managing your clusters, you can also have access to all the monitoring, make sure that you verify all of your resources and how everything is handling the load. So you can really dig into what your cluster are doing and how they are working right now. So MongoDB Atlas is definitely an easy way to get started. And when you want to use all of those with Kubernetes, there is an operator for each of those flavors of MongoDB as well. So there is an operator for MongoDB Community, another one for Enterprise Advanced, and another one for Atlas, which is the one that Mofi will demo in a couple of minutes. But it definitely makes it easier. So now you can manage all of the things inside of this managed MongoDB Atlas service, but you can do all of that through the kubectl tool. So you can create those projects, deploy your databases, and you can make sure that you do all of those, and then you can easily give access to the connection string so that your developers can start connecting to their database immediately and use what they have access to. So that was my very quick introduction to what is MongoDB. If you're not familiar with what is MongoDB exactly, there's a lot of resources that are available on developer.mongodb.com that'll show you how to get started, how to model your data when you're using MongoDB. So it's very similar to, well, just about any other database, right? You're just saving data there. The data models are slightly different and how you use it is slightly different. But once you get used to it, it's a lot of fun to use.
Joel, I think there is one chat comment that I think you can answer right now. Is this version of MongoDB Enterprise support? So yes. I think the question, so I think the question is regarding Atlas. Is it part of Enterprise support as well? I think.
Yes. So both Atlas and Enterprise Advanced have enterprise grade support that are available for you. Of course, a free tier does not come with all the enterprise support. But.
Yeah, fantastic. So I will jump back in again with some live demo. We are, as Joel said, I have pre-provisioned all these things so that we don't have to just wait until Kubernetes shows up and pods get deployed. But I'm going to probably try to run through a bunch of these things again, just so that you can see what is going on. Share my screen again. And Joel, you can give me a thumbs up when you see the screen again. I think you do. Yes, fantastic.
Thumbs up.
Awesome. All right. So if you can see the screen, I'm going to bump up the font just a little bit more so that it's easier to read. And the application we have got going, I think, first open the application so that we know what we're trying to build towards. It's a fantastic bit of application that Joel was kind enough to provide for this. So this is the classic guest book with the fantastic HTML and CSS design where there's fire all over the place.
I love it.
Reminds me of very much like the early 2000 web design, which is very, very, very reminiscent of my childhood.
I miss the marquee tag from those days.
Yeah. So again, this is the classic guestbook application. You have a front end written in React. You have a back end written in Node.js. And as you are like sending request, your request is going through the backend Node.js application, which is talking to MongoDB and creating these individual records of me sending an example, name Mofi, messages hello. And this URL is public. I will actually share this here in the chat. I run the risk of people adding too many messages and running over my 500 megabyte limit, but I don't think that is going to happen. And if that is going to happen, please refrain yourself of sending too many things. But yeah, we can send a couple of messages. I will wait for folks to send a couple. I'll send a couple here. I'm going to impersonate Joel and send a message impersonating him. Hopefully I don't go to jail because of it. But I did that. And another person, another user, a cool web page dude. I agree 100%. And again, this is not live reloading. If I refresh, I might see a couple more messages or not. But as people send messages, it will be stored in the MongoDB database that is running here, which I can go see, browse collections, and then see that all these messages that were sent are here. So I'm getting fourth message that came in as well. So I can refresh the page to see, oh, I have a bunch more messages now, which is fantastic. So again, as time passes, as people send their messages, they're all going to show up here. And I am just rendering those HTML right there. So that's a very simple idea of what is happening. Nothing too complex to explain what the application does, but I'll quickly show you what the back end of it looks like. You are using the MongoDB Node.js client to get access to the database. We have the connection string that will pass as an environmental variable that we will use to connect to the database. And as every time I refresh the page, we run this /entries, which just finds the collection, sets all the values as an arrays, and just sends this back out to the React when React will render them as they see fit. As well as every time you type a message and your name and send, click send, it calls this post endpoint and just sends that to the collection. So fairly straightforward. And we have one more. If you want to clean up everything, I can just call /flush in the application, in the URL that I have running in the backend to clean up the database if I need to. But again, we're not going to do that today. And we also have a front end, which is just a React application. Also pretty straightforward. We have a simple HTML, and we're just rendering the data from the entries into individual entries. All right. So the first step of putting any application up on Kubernetes is containerizing it. So the first thing we do is have a Docker file that is, again, fairly straightforward Docker file. Copy all the file, run npm install, and then as the entry point, set up node dot. So start the application. That's the Docker file for it. And then for the front end, same, we have another Docker file. This one is a little bit more involved because you need to set up, like React doesn't have a server, so we're just setting up that ourselves. And eventually we just do Nginx, using Nginx on top of React to serve the files that React builds. So once we have both of those things, we could obviously test it locally by running the Docker images. So if I did Docker images, you would see that, oh, I killed Docker because it takes too much resources. But you can take my word for it that I had built those images that you could then see if you needed to. You know what? Might as well while we're here. I'll show you what the images look like. But to run anything on Kubernetes, everything in Kubernetes is defined as YAML. And it's a bit of joke here is that there was a post. Someone was joking about having like a YAML engineer as like a job posting, and then it actually showed up a few months later. Again, we are all basically YAML engineers at this point. But again, we're defining our Kubernetes deployment here, which we have a kind deployment. We have a name, we have a label. We're setting 2 replicas, and we're saying that the image we want to use is mofficode /marn-kates-back. You could also use Joel Lord because Joel also has built the same images and pushed them up to Docker Hub. So you could use either. We are saying use container port 5000. So this is the port in the container network we're using. And we're setting a connection string. And the connection string here is coming from a secret. We're going to explain how that secret came to be in a second. But this connection string has the same format as Keith Cuddle, has the same format as this, MongoDB serve, this. Again, this is my username and password, so you could technically access the database if you wanted to, but this database will go away after this talk is done. So you have about 36 minutes to use the database for free if you want to. But again, so this is the connection string I'm passing from this secret to my database. And finally, we have a service, and the service is we're setting this up We are setting this up to target port 80 and opening port 80 there. And in the front end, same idea. We have a deployment, which is using the image, Marin Kate's front, and it's using the base URL to talk back to the service. And the service is also exposed on port 80 and 80. So with all that done, we can see I have again taken the liberty of doing all of that beforehand. So I could do kubectl get pods. You'd see that I'm running 3 pods. 2 of them are the backend pod, and 1 of them is the frontend pod. And this is 2 because it's coming from this replicas to be 2. I could increase that to any number. If a lot of people are coming to use this backend service, I can increase that number. In Kubernetes, you also have the concept of horizontal pod autoscaling. So I could also do things like, okay, if the resource utilization goes over 60%, spin up more pod until you hit a certain threshold. I could say, okay, 10 pods is the maximum I want to spin up, but on low usage time, bring it down to 2. Kubernetes controller will take care of that for us. Okay, so we have this. We also have, we also set up an ingress. So kubectl get ing. You'll see that I have set up an ingress. Kubernetes also have ways to make it like HTTPS endpoint with domain names and all that. I didn't want to do all of that. I just have a load balancer IP address that you can go to access the application, which we can see going here. We are in that IP address. Refresh the page. We see a bunch of these messages coming into this web page.
Hey, Mofi.
Yeah.
I found that different Kubernetes providers have slightly different ways of doing ingresses. Will you be pushing the GKE ingress to the GitHub repo?
Yeah, I can. I can make the change and make a pull request. So what Joel was talking about here is, so ingress by default in Kubernetes world is just an L7 load balancer, like software-defined load balancer, right? So usually you'd see is if you're using Minikube or Kind, you're using something like Nginx as your ingress controller. Most cloud providers, depending on how the network is set up, you could either use Nginx, where you would just set up like a static load balancer and reroute everything using Nginx, or you can have a more custom build load balancer for your particular cloud. In Google's case, we have GCE-based load balancer, which is using Google's like load balancing capability that we have both for internal and external traffic. You get some added benefit of using that load balancer because you don't have to hop through the node port if you use our load balancer, because we have something called NEGs, network endpoint groups, which directly can target a pod IP instead of having to do 2 hops to go through node ports. So if you're using Google managed ingress controllers, your network traffic would be like a little bit faster because you're not taking 2 hops. Instead, you're directly targeting the pod. But again, if your application depends on Nginx, you can always run Nginx yourself and do that, or any other third-party third-party Nginx ingress controllers like HA proxy or traffic or Kong. You have a number of them available that you could use. Another thing I wanted to quickly show you is the Kubernetes cluster we're using here. So the cluster we are using today is an Autopilot cluster. From our use case, all the Kubernetes commands, all the things we're doing, there is nothing different. But the only thing that is different here is if I look at my cluster, if I look at my nodes, hold on, let me just quickly do this. So if I do kubectl get nodes, you'd see that all my nodes, I have like a bunch of these nodes, but I am actually not charged for these nodes. I'm charged for the pods that are running. And if the pods go away, these nodes will eventually automatically actually shut off. So if I were to delete all my pods that are running right now, my cluster will scale down to 0 nodes, which is basically the serverless aspect you want to do, but at the same time, get the full API capability of Kubernetes. So the thing I was talking about earlier, the best of both worlds. All right. So this is like the classic use case. You set up all the secrets, all the thing yourself. Where does the operator come in? And so we're going to talk about that now. So Atlas Operator, what it lets you do, instead of me having to go to this URL over here, clicking buttons that Joel was showing, which is fun. I love clicking buttons, but at the same time, this is not repeatable, right? Like if you miss clicking one button here, tomorrow your database doesn't work because Mofi forgot to click this button he was supposed to, right? So we don't want that to happen. What we want to do is define our infrastructure in a way that can be repeated, that can be redeployed if something goes wrong, as well as we can see what we did. We have like a track record of all the things that are currently running on your cluster. So that's the whole idea of infrastructure as code, right? All my infrastructure should be defined as code as much as possible. In this case, what we're defining here, I want to create a new Atlas project. I want this kind of, Atlas project, and I want to set up like the IP rules. I want to set up all these things, but they're defined in code now. So if tomorrow you want to deploy the same application, some other data center, I don't have to reinvent or remember what I did last time. I just come here and reapply the same thing. And next up is we have a create a deployment. We can define what kind of resource we're using. Again, we're using M0 here because we want to get the free 500 megabyte tier. But I think in the docs you can find, but we have different kinds of machines depending on your particular use cases.
Exactly. And in this case, you can also specify the provider that you want to use.
Yeah.
So you would use GCP with the Eastern US in this case, in our case.
Perfect. So also we're defining new user. Again, you can redefine this user. You can also create users, I believe, that uses secret, like the key, not the password authentication in Atlas. Ideally, you probably want to use something like some public key-based mechanism where you're not having text password there. Once we have done all of that, we apply those things. So API, Kube, CTL, API, resources. I want to show quickly all the resources that comes from MongoDB Atlas. So this, once I install the MongoDB Atlas operator, these are the new resources that became available onto my cluster. So the first one we saw is database user, where you can create a new user, deployment, where you can create a new database deployment, Atlas project, where you can create a new Atlas project. A couple of the other ones we are not using here today, but you can kind of by reading it can see what they would do. One is backup policy. You can create this custom backup policy that backs up your data in a particular interval, as well as schedule, like what interval they're doing this in. So they're pretty like self-explanatory by the name of it, what they would probably do. But documentation covers how to use those things. In our demo environment, I don't think backing up our hello datas are that important. But again, your application obviously has a lot more importance to do those things in a periodic manner. All right, so I already did all of those things, and I quickly want to show you what happened as I did them. So I have two projects that are created under my org. So number one is the one I had created yesterday, which was project 0. And I have a couple of data there probably as well. I have no data right now at this point. Oh, no, entries right there. I have two sets of data in that point, right? As I was practicing this by manually creating the thing. But when I wanted to use the operator, I pretty much did the exact same thing, but this was created not by me, but the Kubernetes Atlas operator that automatically created this data as well as the database. I think oftentimes using operator, you might think, okay, there's nothing fundamentally different, and which is the case. It shouldn't be any different. The use case, like the experience of a user using the operator should exactly be what it would be if I were to click the buttons. So one thing I can try to do is run the operators again, but by changing some data and see what happens if I break something. That could be fun. So I'm going to create a new one, but we're going to call it demo gods help me, right? So every time something breaks, it breaks in the live demo portion of things. So I'm going to obviously, and also if you see me typing K instead of kubectl, because I said an alias, anybody who types kubectl more than 50 times probably said this alias to make their life a little bit easier. So I
actually did the same alias, and I think that came from you, which is probably like the best time-saving tip that I've ever had.
You get so used to typing. So I'm going to create this new Atlas project, and from your like a user's point of view, I could now do kubectl kget Atlas project. Not only we now have access to like this Kubernetes-based resource that I can do things with. On top of that, now I can check the existence of these things also from a Kubernetes environment, right? So we basically created two-way tie between the resource that we have and the place we're using the resource in. Kubernetes now knows this project exists. Before, when I manually created by clicking a button, this database exists, my Kubernetes cluster exists. Now I'm manually putting some connection string to talk to it. But now with the operator, my cluster now knows this thing exists, right? So that is Extremely, extremely powerful. Okay, now you can see that immediately a project was created. Demo gods helped me, and demo gods were on my favor in this day, which is great. And that is what we expect, right? We create a new project that gets created. Next, we want to create a new we're going to create a new project under that same thing. And now we're just referencing this Marn Cade's project, which is talking to this particular project. So we don't have to do anything extra, but I will just change that to, is it called GCP or Google?
Try to change instance name to an M10. Oh, no, is that going to work? No, keep M0, keep GCP, and then Eastern US for the region name.
So not US East, or this is
fine. No, it would be Eastern US.
Okay. I am not going to change it then because I don't trust me to remember what the name is. So cluster demo, we're going to try this and see if this works. I think the name shouldn't be spaced. I'll do this. I'll just keep it there. There you go. It's fine. Atlas Deployment. Okay, so I just did that, and it's going to take a second, but there is a, okay. Quickly, another thing I want to show you what we also did because I said this before you showed up, so you probably don't know what's going on. So kget ns, you'll see all the namespaces, and I have this MongoDB Atlas system namespace. If I were to do kget po-n MongoDB Atlas system, there is this operator application running, and all the things we're trying to do using the Atlas operator is talking to this application, and this application now is a reconciling loop that's constantly listening for changes in the state, and it can take effect based on what we're trying to do. So if I were to do this, if I did this right and go into this, and you would see that this cluster demo is being deployed for us. So as an idea, it's fairly simple. Like we ask this reconciler loop to do something. It goes, calls the API to do this, and it just takes effect whenever it takes effect. It's nothing different than me coming here and clicking create and selecting database, yada, 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 all this fun stuff. So yeah, so eventually this will get created. We can also create secrets to be able to pull that data out of Mongo as well so that we can pass it off to our application. And that's what we do here in our deployment. As you can see here, we're setting up this value of connection string from the secret key, which got created, kget secret, this Marn Kates cluster 0 Marn K8s. So kubectl secret, get secret, and we're doing some JQ magic to convert that JSON object and convert that directly into base 64 decode, and we can see what the connection string of that would have looked like. So yeah, that's all I wanted to show with operators. We do have about 20 minutes ish left. I will leave it up for people to ask questions, how to use this. One thing I also had shared in the handout section is how to okay, I will get to the question that we have there. But if you look at the handouts, there is one, the top link there is MongoDB Atlas Workshop. That's a workshop Joel created and was the basis of a lot of this demo that you have seen here. And you can basically run through this workshop. You can run most of this thing without having to pay a dime out of your pocket because you could always just use local Kubernetes distribution like Kind or Minikube. If you want to use Google Managed Kubernetes, if you sign up for a new account, you get $300. That would last in Autopilot world like months, because Autopilot, when you were done using it, it'll scale down to 0. That is fun. Also, another resource I would like to use, I like to use learning Kubernetes, is Cloud Skills Boost. So if you go to like cloudskills.google, or I don't even remember the URL. There you go. If you go to this website and sign up, there are a bunch of courses in here that are free. And what this does is a sandbox environment on Google Cloud that you can use to try out different Google resources, such as like BigQuery, Kubernetes, Vertex AI. Some of those will say requires like credit. Credit is subscription, but many of these courses here would be basically free if you just like sign up for it. So when you click a button, that'll give you a brand new Google Cloud account with like an hour or hour and a half to play around with it. That is plenty of time for you to explore different like Google Cloud services for you to try it out. Yeah, we're just about at 40 minutes. We want to keep as much time possible for Q&A. I see one question is, how can I manage multiple GKE clusters? Do we have a Google native managed service? So there is two sets of answer to this. So number one is managing multiple Google Kubernetes cluster would probably be the best place would be to look through the console to see what you can do. There is another product that's currently in private preview for most of, but it is, we call it Fleet. And Fleet is the way you can manage multiple Kubernetes cluster at the same time by giving upgrade commands, update commands, all of those things. But that is not yet generally available. So that is in the future that's coming. The other thing is, I know a lot of like large scale companies that uses Kubernetes uses it this way is define all your Kubernetes workload in some sort of infrastructure as code system like Terraform or something similar. So what you can do with that is that if you have to redeploy everything and manage or change something about all of those things, you use it on a defined system rather than going through the consoles and manually clicking buttons. So that would be the way to, I would say, manage multiple Kubernetes clusters.
Yeah, and if I can add to that, if you're using multiple JKE clusters, you can even use the same database and make sure that the replica is duplicated across all of those clusters. So by using the MongoDB Enterprise Advanced Operator, you can actually deploy your own instance of MongoDB and make sure that all of that data is spread across all of those different clusters. So we just released a blog post series about that. I've added the link into the handouts if you're curious about it.
Fantastic. Yeah, and if you have any more questions, comments, you can always drop them in the Q&A or the chat. Another thing is, I think there is delay probably between us saying, so sometimes if you have more questions about the things we just said, keep them coming. We'll answer them as they come. And we have about still 20 minutes left. So we'll keep this time for any questions. It doesn't even have to be related directly to the things we're talking about today. Joel brings a lot of expertise in this space, not just MongoDB, but also Kubernetes and managed Kubernetes or just open source Kubernetes. So if you have any questions regarding those, we'll try our best to answer.
Yeah. In the meantime, tell me more about the JKE Autopilot, because I stumbled on it when I was trying to do a dry run earlier today. But I was kind of curious, like, how does that work?
Yeah, so Autopilot is a new way we are trying to introduce Kubernetes to the general masses without having the... So I think I'll go back to that slide that I was showing earlier. I think that will make the most sense again. So when you're talking about you want to deploy application, when you're talking about Kubernetes manually, like open source Kubernetes, this big circle is what you're responsible for. You only care about the green space still. The application is the one you care about, but you're responsible for monitoring. You're responsible for scaling up and down. When new upgrades and patches come, you're responsible for those as well. So in the service of being able to handle your application deployment, you end up taking on these 7 other jobs that you didn't ask nor do you care for. Right? So that's where managed Kubernetes is really valuable, because you are responsible for the worker nodes provisioning and management, right? You design and define what worker nodes and what kind of VMs you want. And on top of that, you are also responsible for security, right? On standard GKE, you are allowed to create something as privileged. You can give admin permission to all containers, which is a major security risk. So this kind of things you can still do. But again, this is still better than having to manage all 7 things. You are only managing 2 extra things on top of your application. What we wanted to do with Autopilot is make sure that you only need to care about the application and nothing else. The node, you never care about node. You just define your deployment YAML, click apply, and Google Kubernetes Engine will determine how much resource would you need and deploy a new node for that workload. If it already doesn't have enough node workspace, like node space, it will deploy a new node. And as your workload go away, those nodes will be eventually deleted. So you are never charged for nodes that are running in the cluster. So in a regular day, if I were to do kget nodes and I saw 5 nodes running, I would be like, oh my God, how much money am I spending on this? But I am not spending any money for any of these nodes because I don't pay for nodes. I only pay for kget pods, right? I'm only paying for the pods that I'm running. So that is kind of like the difference between Autopilot and GK standard. So there are some differences, and some of those differences make few like select workload not feasible for Autopilot. For example, if you're using like an application that needs to have root access to the underlying system, Autopilot would not let you have that. If you set in your deployment, if you set something privilege true, Autopilot would actually fail from deploying that application. So some use cases that are difficult to do this way would be if you're trying to run like some sort of aggregator that collects data from a bunch of nodes. That doesn't work directly as is on Autopilot. So there are some workarounds, obviously. You can run daemon sets, and that is also more Kubernetes native anyway, as well as that is more secure, right? Giving nodes and pods privileged access is just like a recipe for failure and disaster. Because if, God forbid, one of these containers escape, in the root process, host process, they'll end up being the root, which you never want in a VM environment. So yeah.
Cool. And the more I can automate all of my stuff, the better. Like I don't want to deal with any of that deployment stuff. So that's great.
Yeah, and again, we always gonna have support and always gonna have GK standard. So if your use case like dictate that you need to have access to these very specialized types of VMs and other things, you can always have that. Even in GK Autopilot, we're actually bringing support for things like GPU even. So if you're running like machine learning models, even for that, you don't have to worry about what nodes you're running, right? You just have GPU connection, all of that works. I think there is another comment. I will read it out and you can probably answer. Does data service orchestration enables us to centralize and structure our works by projects that are natively isolated and secured? That's a mouthful. So I'm going to let you read it again. And
I'm not sure what the question refers to.
Yeah, I think a little bit more clarity on what.
Yeah, the data service orchestrator is. I'm not fully sure I understand the question. Yeah, if you could clarify that question. In the meantime, I said there's another question about does MongoDB support automatically data isolation for different customers? And I'm not sure if that's actually related to the other question, but yes, there are ways to automatically do that data isolation. So you can definitely shard the data across different clusters for each one of your customers. So that's one way to do it. There are many different ways about how you're going to architecture your data that can define it and make that fully automated. But that's yes, but it's definitely possible.
Yeah, and there's another question. I'm guessing it's for me because it's talking about cloud functions versus GK Autopilot. So if I could, and I probably should at some point, draw this line of pure serverless to pure infrastructure, or maybe the other way around. So at the most left of the pure infrastructure, you have bare metals, right? So you can have a hardware that you're running your application directly onto those racks. Usually we don't want to do that because it's too direct, and getting access, getting resources like this is really complex. So we move one layer above and we use VMs. So we have VMs, which you can get access from anywhere in the world. You can run your application there. On top of that, now we can run Kubernetes on top of that by abstracting the VM access. And Kubernetes is great, but you are still always paying for the VMs you're using, even though your application doesn't probably use all of the VMs. So on the farthest edge, we have cloud functions where you define one of your workload or one function, and as workload come in, those functions execute and do things. But the problem with that is it's very complex and expensive then to do where your workload requires 3 of those functions to work together, because there is no way to have one function directly talk to another function without making an API call over the internet. That's a fairly expensive process if you want to do it this way. So also, it is also difficult to get all the libraries and things that you need to be running inside a cloud functions, because cloud functions, by definition, is a limited runtime. You don't have all the bells and whistles of the language of your choosing in cloud functions, even if the language is supported in cloud functions. So if you move one step towards the infrastructure side, you have Cloud Run. So Cloud Run, you can define a container, put all your dependency in there, run it, and Cloud Run will be able to do all the language specific things that you need to do. Challenge still is if you if you have application that needs 3 of those Cloud Run instances to talk to each other, you're talking over the internet, public internet, to be able to make API calls. Expensive, slow, you don't want that. So one step on this way is world of GK Autopilot, where you have the benefit of your application only being charged for the pods that run, but also have the benefit of being able to run multiple pods that can use Kubernetes native internal DNS to talk to each other for microservice application without having to go to the public internet, right? So Autopilot is kind of like the middle ground between like open source Kubernetes and Cloud Run, where you don't have access to any of the infrastructure. But on regular Kubernetes, you have access to too much infrastructure. GK Autopilot is in the middle, where you have access to the infrastructure in the sense that it matters, but not in the sense that you have to pay for it.
Yeah, and you raised a good point. When it comes to network traffic, that's always a big issue. And it's the same thing with your database. You don't want your application to always go through the public internet in order to get your data. Even if it's much easier to have everything managed in Atlas, that connection can be costly. So you can actually set up peering. So if you deploy your databases, and that's one of the big benefits of MongoDB Atlas, is that you can pretty much pick wherever you want, like on any of the major regions. You can specify which region you want to deploy it in, and then you can set up a VPC connection that will use the internal routing rather than doing that external connection over the public internet.
Yeah, and the moment you're going to the public internet, you are dealing with SSLs, handshakes, and every time you make a connection, you're spending more resources and time to do those. In VPC peering, first of all, with being able to choose the region, you can already put the database closer to where your application is. So that itself decreases the latency. On top of that, now you can also say things like use the internal network instead of external, which is generally faster.
Yep. So it seems like we've got a little clarification on the question. With Data Services Orchestrator, can we configure authorization level as access rights for each project, editing rights by role and access? So I think Data Service Orchestrator, you mean the Atlas Operator? That's my understanding. If so, in that case, yes, it's possible. Mofi showed us the Atlas database user configuration, like when well, yes, you can create your users there directly. From there, you can specify which type of user you want, and you can specify the permissions for that user that you're setting. Or you can use a certificate as showing right now. But if you go back to the password tab on top, those will define a new Atlas database user. In this case, we're using the UI to do it, and there's privileges. Yeah, that's the one I was looking for. Good thing you practiced this more than I did. There's also the built-in roles, which will specify which database you have access to, if you can create new databases, which collections you want to give to that user, and on and on and on. All of that can also be defined in the YAML file, in the Atlas database user YAML file, and then you'll be able to create it from there and manage it from there. And the users using, or the software developers that have that connection string that is built by that by that specific database user, then will only have those specific access by the application. So I hope that answers the question.
Yeah, so I'm just opening up the database user custom resources. You can see all the different things you could set up here. So the documentation I found to be very, very easy to navigate, which was big kudos to the team that works on documentation.
It's an amazing documentation team that we have. Can you just zoom it in? Just one?
Yeah, I'll make it a little bit bigger so that it's easier to. Oh, yeah, that was the string I was looking for. Okay, cool.
That's the one.
Yeah, fantastic. Okay, so if I were to, and I'm going to show you one more thing. This is a not necessarily a MongoDB documentation thing, but it's a Kubernetes thing. That's another benefit you get for building operator on Kubernetes. So I wanted to say this. So if I want to learn how the Atlas deployment object works, right? I want to know what's in it and what are the things I need to be, what I can do it. So I can, in Kubernetes, there is a command called explain. So any Kubernetes native resource, you can actually run explain on. And operators become a Kubernetes native resource. Now kubectl can understand it. So I can do kubectl k-explain Atlas deployment. Where did I do it? Okay, right here. I called did k-explain Atlas deployment. So I can dig deeper. I can say, okay, show me what's in spec. Okay, it is telling me this deployment spec is in spec. Okay, I want to know what's in deployment spec. So I can do deployment spec. And it will tell me all the things, all the like the mini flags that I can set in this deployment spec object. So I can always obviously read docs, but if you're feeling like, okay, I don't want to deal with like reading the doc, I just want to know the structure of it, I could also say recursive. It will give me like the YAML structure of all the things under the deployment spec object. So if I want to set all these tiny bells and whistles, I can go through and add all of this myself. Again, documentation covers all of this, but if you want to just have a more Kubernetes native way to look at documentation for native Kubernetes objects, this is the great way. And I learn quite a lot every time I use the Explain command.
That I must admit, I didn't know about that.
Oh no, kubectl explain is one of the best commands that exist under kubectl. Especially if you're trying to write a fairly complex YAML structure and you're getting errors, you don't know where it goes. And this is even more useful when Kubernetes deprecates or switches around a couple of the API definition and your old YAML files no longer work. So you can basically get the kubectl explain recursive to get the new YAML structure and map it without having to read through like a bunch of old documentation that probably no longer works. Yeah. So also like since you can create X509 certificates, you can also think about using Cert Manager and rotate certificates like automatically using Kubernetes. So as I'm like looking through the Atlas operator and like all these ways to connect to your database, I'm basically seeing all the different ways you can automate the process of securing your application and keeping it secured, right? Ideally, you don't want to ever have passwords that are just available. And I'm pretty sure MongoDB Atlas operator also works with Vault, where you can like inject a password on the fly, so that you don't have to ever have this password text just available, things like those. So yeah, I must admit, like this is like the first time me using also the Atlas operator, and it was really fun to use. Yeah. Couple more. Yeah, we have like just a few more minutes left. Any closing remarks, Joel?
No, I mean, that's great. I've learned so much about the GKE, playing around with it in the last couple of days, but also the things that you showed me about the autopilot and all that stuff, that's really cool stuff, and I can't wait to play around with that. So yeah. Thanks a lot.
I think, yeah, so with that, a couple of minutes left, I'm going to pass it back off to Cody. I think there are some survey questions. And please feel free to surveys. We love to do this, and we love to learn what we can do better. I know we can always do things better, so let us know what we can.
Awesome. Mofi, Joel, thank you both so much. I really appreciate both of you joining us and taking us through not only the demos, but answering the questions and really providing this in-depth look. So thank you both so much for this packed hour. So to our audience, since this session did have so much going on, if you wanted to rewatch the recording, it is going to be available on demand. You will be receiving an email with a link to access that recording, or you can find it living on the DevOps website at devops.com/webinars. So we do still have those 4 $25 Amazon gift cards to give out. Our winners are Eric R., Sharam S., Claude N., and Chris K. So to our 4 winners, please keep an eye on your inbox to claim your gift card. But if you don't happen to see that email, check your spam folder. I'd like to thank Google and MongoDB for sponsoring today's program. We could not have put on this program without the help of our 2 sponsors. And to everyone who's been with us today, thank you so much for being here. As Mofi mentioned, we do have a survey that will be popping up as soon as we close out. We've also added a couple of extra questions there on request from our sponsors. So do feel free to let us know what you thought about our program today and provide us with some honest feedback. Otherwise, we do hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day, everyone, and you may now disconnect. Joel, Mofi, thank you once more.
Thank you.
Thanks, everyone.